Everyone, so we are going to do a very quick one, so to just finish the last two examples for yesterday's lesson. Okay, so question 6, Marian is injected with 60 ml of a pain-killing drug. Every 4 hours, the amount of drug in her bloodstream is reduced by 40%. To compensate for this loss, she needs to take an extra 15 ml. Okay, so which means that initially there's like 60 ml of the pain-killing drug for the first injection. Okay, so after the 4 hours, then the amount of drug will reduce by 40%, so left with only 60%, right? So that's why to meet up of this loss, so she need to take extra 50 minutes. I guess that's like very straightforward. So for this question, I'm going to show you two approach of a different value of n. But at the end, you are still getting the same answer. So my main point is still the same. I always tell you guys that what is more important is that you must understand what are you doing. So try not to memorize like this approach, or you try to memorize I should do like this, I should do like that. But when you try to understand the whole situation, then you know what to do. Okay, so yeah, let's start with the question A. So find a recurrence relation for the amount of drug in Marian's bloodstream. Okay, so let's try to do the first approach, which you guys always do. So we try to write, so this is pain-killing drug, so maybe we try to do D, okay? So dn will be equal to, so reduced by 40%, so how much remaining in the bloodstream is 60%, so that's why 0.6 of the previous injection, right? Okay, then after that takes extra 15 ml, so that's why plus 15. Okay, I hope that you have no problem to write this. Yeah, okay, so basically you just understand the question. Okay, so in this case, I think it's very obvious that you will write your D1 as 60. So this is like your initial term. Okay, so now, right, I'll show you the other way of doing it. Okay, the idea is you have a choice if, let's say, the question didn't give you what is that meant by your n. But if, let's say, the question give you what is represented by the notation n, then you must follow the question. So in this case, the question didn't give anything, so it will be depending on you, because at the end, you are still getting the same answer, although your recurrence relation, the initial term is different. Okay, so the other approach that you can try to do is the recurrence is the same, but then the only difference is that when you try to write it, you doesn't want your one represent the initial term, because you want your one represent after the first 4 hour. So which means in this case, what you have is your D1 will be straight away equals to the amount of the drug in the body after the first 4 hour, which means you will substitute 60 then plus 15, then you are going to get 51. So that become your initial. Okay, so I hope that you can see the difference between these two questions. Okay, you have the same recurrence, but you start with a different number. The reason being is that the n that you are trying to set here, they means different thing. So the n that you are trying to set here is like for the first dose, you are getting 60. Then second dose after the first 4 hour, then you only get 51 and so on. But my D1 here actually meaning that after the first 4 hour, I got 51. So when I do after the second 4 hour, then I will do D2. So that's the idea. So for this one, another alternative that you can try to do is you can see that the term before 51 is called as D0, and that's basically 60. Okay, so that's like alternative here. So that's why both can be accepted. It's just that you start with different term, but you understand what your term means for you. Okay, but let me emphasize it again. It's because of this question didn't restrict us what is the n that we must use. So that's why you have a choice. If let's say the question did tell you that the n meaning like number of hours after the experiment start, then you have no choice, but you need to put in like relevant n for that. Okay, so that's the idea. Okay, so let's move on to B. How much of drug is present in her bloodstream 12 hours after the initial dose is administered? Okay, so you see, if let's say we try to use the first one, this is like our first dose, right? So after the 12 hours, then which means that she takes how many injection already? So the first hour, then you have second injection. Okay, so which is D2. after second 4 hour, then you have D3, the third dose. Then after that, then you have D4, the fourth injection. So that's why if let's say you are using the purple color recurrence relation, then you should get D4 will be equal to 42.36. Okay, I hope that I do not need to show the calculator working here because you should be familiar with the generating of sequence already, right? Okay, so now if let's say you are using the other one, so which means if let's say you are using the second one, then how is that going to look like? Okay, so which means that you start with 51. Your 51 meaning after the first 4 hours already. So you want 12 hours, right? So after second 4 hour, then you get your D2. Okay, so I hope that you get what I mean, right? This is like the first 4 hour, then second 4 hour, and then after that we continue with D3, and this is your third 4 hour, and that's basically the thing that we want to find here. So which means in this case, what we are going to find is our D3. Okay, which when you try to generate another sequence but your D1 is 51, you are going to get the exact same amount also, which is 42.36 ml. Okay, so yeah, like what I said, what is important? The important thing is you understand what you are doing. Okay, because at the end you are still getting the same answer. Okay, see, eventually the amount of pain-killing drug in Marian's bloodstream stabilizes. Okay, in long run, how many ml of painkiller will be present in the bloodstream after she received her dose? Okay, so in this case, then, if let's say it's stabilized, right, then which means that is in the long run, it will be a steady state. Okay, so you can always try to check your your recurrence relation here. So in this case, you can see 0.6. So it's a number that is between -1 and 1. So that's why this recurrence relation will give you a long-term steady state solution. Okay, so the question wants us to find out how many ml of painkillers. Their recurrence is the same, right? So no matter which one you are using, so they should give you the same answer. Okay, at steady state, so you have your Tn equal to n minus 1 term. Okay, so x equal to Tn equal to Tn minus 1. Okay, so let's substitute. So x equal to 0.6x plus 15. Okay, so move this to the left hand side, 0.4x equals to 15. Okay, then our last answer, x is 37.5 ml. Okay, so you can check through your calculator as well. So you should get 37.5 in long run. Okay, so that's basically the part for question 6. Let's move on to 7. Okay, question 7. Daniel wins 200,000 in the lottery. He invests this sum in an account that earns 0.5% per month, compounded monthly. So for each month, he will withdraw like 800 from the account. Okay, so the question wants us to find out the recurrence relation that model the situation. Okay, so in this case, I'll show you another way to do it as well. So the same thing is just that you are going to understand how your calculator generate the sequence, then how are you going to write your answer, okay? So I hope that the different approach didn't make you confused, but you understand how your calculator works and how different recurrence relation initial term works and how what is the meaning that it brings to you, okay? So in this case, then I think the recurrence relation is not hard. So in this case, it's about money. So maybe just put M. Okay. So the current money is equal to, so you generate 0.5 interest, right? So which means it's going to be 1.005. Okay. Times the money in the account. Then after that, he withdraw 800 from the account, so minus 800 from the account as well. Okay, so in this case, then let's try to set our end here is like after how many months. So it will be easy when we try to find out the question which they ask like how much money in the bank like after how many months. Okay, so in this case, maybe we just try to put M0 here, so which is like our initial term. Okay, so this is before it earns any interest and before he withdraw any money. So this is the initial money in the account. So that's why we write M0 here. Okay, so now let's try to move on to question B. Okay, sketch the graph of the value in the investment as a function of time in long run. Describe the trend. Okay, so in this case, you have 1.005. So that's why by looking at this, then you know that it won't actually reaches a stable state. Okay, sorry, a steady state. Okay, that's a very logical thing because you can imagine if let's say this recurrence relation generate a steady state, right? Then why if people want to put their money in the bank? Because if let's say it will reaches a certain steady state, then what's the difference between I keep the money at the home or I keep the money in the bank? Okay, and because of normally how do you define steady state is that the number, the ratio that you have here, right, is a number that between between -1 and 1. So that's why if let's say you have like 0.09, then which means that you even lost the money during the long run. You get what I mean? Because when you write 0.9, then which means every month you lost 10%. Every month you lost 10%. If you lost 10%, then who else want to keep their money in their bank, right? You keep the money in the bank, then after that you earn interest. In that case, you will surely have a ratio that is greater than 1. Okay, because it only makes sense that it's earning the money. Okay, so in this case, then you know that it's supposed to be a increasing one, but you're not sure that whether the withdrawal will actually make it become decrease or not. So let's generate the sequence in our calculator then. Okay, so let's try to generate it. Data. Okay, generate sequence. So 1.005 U n minus 1. Okay, and then minus 800. All right, so just now we put M0 as 200,000, right? So you're wondering what do you need to put for initial term? Okay, so don't worry, you can put 200,000 and later I'll show you how can you read your calculator properly to get the right value. Okay, so in this case, let's try to generate for 2 years, I think, because when you try to look at answer C, right? So the thing that you have is how much it's worth after 1 year. Okay, so we doesn't need that much. So maybe 24. All right, then okay. So in this case, then we want to see how's the trend. Or okay, actually by looking at the sequence here, you can see that the increment you have, right, is more than the previous one. So from this term to this term is like increasing 200. The second one to the third one increase 201, then increase 202, and so on. So you can imagine that for everything, the increment is like increasing as well. So, but if let's say you want to try it out, let's try to do it. So 1, 2, 3, 4. So let's try to generate the graph. Okay. But just to bear in mind that you should be able to imagine the graph in your mind because it's not the case where all the question you can actually generate a sequence and you can try to check it out. Sometimes it will be difficult. So that's why you, by looking at all this number, you should know that you will have an exponential. So things like increasing to infinity, and then it will be keep on increasing after that. Okay, so but then let's try to look at the graph and see whether it can tell us or not. Okay, so add another page. Okay, then data and statistic. Okay, so N and this is A. Okay, so the thing is not very obvious here because the number that we have is like quite the range is too big already, so that's why you can't actually see the line like very clearly. Okay, so like in this case, right, then you are the one that need to decide how you should draw it. So by looking at all this, you know that they do not have a common difference, right? Because the increment is different, so that's why you should know that it's not a straight line graph. And last time, if you can recall, when we tried to do the first order recurrence relation, you have only 3 types of graph. It's either steady state, increasing or infinite, then or decreasing infinite. So in this term, you can see that the increment become bigger and bigger. So from here to here is 201, here to here 202, from here to here 206, here to here 204. So that's why you can imagine if you keep on continue this routine of earning interest, withdraw 800, so the investment will actually keep on increasing until infinity. So in this case, it's an exponential. But don't forget, in this case, you are starting with 200,000. Yeah, it's not starting with zero, so it cannot pass through the origin here. So that's why the graph that you have is supposed to be like this. So just move on to infinity because the question asks for long run. So in this case, then this will be your initial value, which is 200,000. Okay, so that's the idea. This is like the number of months maybe. So we can try to put months as a function of time lah, or in this case it's like time. Okay, so during the 0 month, the initially you have 200,000. Then after that, oops, sorry, my fault. Okay, so in this case, then this is the time. Okay, the month, and then the y-axis is always the investment. Okay, sorry for a mistake just now. Yeah, so that's basically how you draw the graph. So in this case, the important value that you need to show is the 200,000 here lah. The rest is okay because you don't have any specific value to label. Okay, question C. How much is Daniel's investment worth after 1 year? Okay, so you see, you put M0 as 200,000, right? Meaning your M1 is after the first month, M2 after second month. So after 1 year, which means after 12 months. So that's why you are getting M12. Okay, so now you have a question. So we are writing M0, so that's why we put M12 here. But in our calculator, our M1 is 200,000. So what you should read? So you are writing 0 in your equation, then your but is 1 in our calculator. So that's why if you want M12, then which means in your calculator you should read M13. Okay, I hope that's clear, right? Yeah, that's the idea. So 202467.11. 202467.11. So remember, this is money. So that's why two decimal places. Yeah. Okay. So that's the idea. So you should check it out like that. Okay. So I hope that you get it because it's M0 here. You are writing M12, but in your calculator, this is your M1. So you are reading M13 for your M12 here. Okay. Okay, let's look at the last question. After how many months will the amount of interest that Daniel has earned on his investment first exceed 3,000? Okay, so for this question is a bit tricky in a sense where you need to understand how this thing work. Okay, so don't worry about that because for your coming test, right, it wouldn't be involved anything for financial mathematics because I want to differentiate in a much more clearer way, like even for financial mathematics, you are using the concept in growth and decay, but I doesn't want to confuse you because some of you might not sure what's the concept of investment, interest, withdrawal. So we are going to look at that part in a much detailed way when we move on to unit 4.2. But for this question, we are just going to take it like a challenging question and we try to solve it. Okay, so why is this question difficult? It's because of when you try to look at the recurrence relation that we have, right? This recurrence relation tell us how much money do you have in the bank for each month. It didn't tell you that how much interest it generate. So it's the same thing when let's try to look at the interest, the sequence that we have. Okay, you see the difference between the month, right, is going to be like, you can see from here to here it's like 200, from here to here is like 201 and so on. Okay, so you might say that the difference between the money for each month is going to be interest. Is that correct? Okay, so this concept is correct if, let's say, for this question you only put your money in account without withdrawal. So it means that you put in some amount of money, after 1 month it generate the interest, then after the second month it generate the interest. So that's why the increment that you see in your account is basically because of interest. Am I right? But for this case, right, what happened is that he invests the money, then after that he earns interest. So after he got the interest, then at the same time he do withdrawal as well. So that's why some of the money that he withdraw, right, might be from the interest. So you can't actually know the interest from the sequence itself. But how can you do that? So meaning that in the sequence, so the difference here is 200, but at the same time, you need to understand that he withdraw 800 as well. So the difference between first term and second term, let's say, I'll try to write here so that to make you understand. Okay, so you can see after the difference between, the difference of the account between the first one and the second one is 200. Okay, at the same time, he withdraw 800. Am I right? So that's why actually this account earn 1,000 because this account earn 1,000. So that's why after he withdraw 800, then only he left with 200. So that's why the account only show 200 increment. Okay, so that's when you try to check with your scientific calculator, right? You can try to press for the first month 200,000. When you multiply 0.005, you should be able to get 1,000 as well. So from there, then you'll be able to know that for this amount of money, it will generate 1,000 interest. So after it generate the interest, I take out 800. So that's why the only increment that show in my account is the 200, which you can see from the sequence. Okay, so same thing when we move on. So you can see the difference between these two terms is 201. So same thing, you take out 800, right? So which means how much money do you really generate? It's 1001. Okay, because it generate 1001, when you take out 800, then you're still left with 201. So that's why your account increased 201. Then when you move on to the next one, so this should be 203.005. Okay, so same thing, you withdraw 800. So that's why how much you earn here is 1003.005. So in this case, you will be able to see that these three numbers, when you add up together, it already give you a number that is greater than 3,000. Okay, so I hope that you can understand the idea here. So how are you going to write it? So don't worry about that because this is a question that I wish you to understand how to think about it. So you can straight away just like copy what we have for the column. Okay, then after that you can write down for these three sum is already more than 3,000. So which means that after 3 months, then you will have this amount already because after first month you get 1,000. After second month, accumulately you have 2,001. So after the second month, then you have like 3,004.01. Okay, so let's try to copy that in our answer sheet. Okay, so from the sequence, so we have 0t, maybe you can try to write like that. Okay, so our money 0, then M1, M2, M3. Okay, so our M0 just now is 200,000, right? So the second one we have 200,200, then 200,201. Oops, 401 just now. So 200,603 if I'm not mistaken. Okay, all right. So 005 if you want to write like it's 0.01 is okay as well. All right. Okay, so you can see you can check out the increment here. So which means in this case, after the first month, it increased for 200, increase for 201, increase for 202.01. At the same time, Daniel withdraw a fixed amount of 800 every month as well. Okay, so that's why the total interest generate, it will be equal to the sum of the increment and also the withdrawal, which is 1,000. 1,001.08. Do I do? Oh yeah, that's correct. 1002.01. Okay, so which means in this term, then it will be after 3 months. Then you can try to write down also the total money that he earned after 3 months. So the total interest, I mean, don't worry so much about like why is it so long because when you move on to financial mathematics, then it will be easier way to do this. But I'm just explaining this in a much more general approach so you can understand it. Okay, so that's the idea. After 3 months, then you earn this amount of money. Yeah. All right. So I hope that you can understand. So let me know if there's anything that you find it like difficult. So yeah, that's pretty much for the two examples here. So remember to spend some time to finish up your question and so on, and I'll see you on Friday's class. All right. Thank you.